Hey guys, today we are going to be talking about classifying matter. You might remember from your physical science class that matter is anything that has mass and takes up space. So we're going to talk today about pure substances and mixtures and what falls into each one of those categories. Those notes can be found as a blank document in the Unit 1 folder under this week. If you guys are interested, you guys can take notes as you follow along with our ED puzzle assignment. Pure substances are made up of one unit. It can be one unit alone, or it can be one unit that repeats itself over and over. An atom is the smallest unit of matter that retains the properties of a specific element. Because we can only see atoms using a scanning tunneling microscope, in this class we will use particle diagrams to represent changes in matter. We will use different shapes and different symbols to represent different types of atoms. So here, each one of these shapes represents a different type of atom. An element is only made up of one single type of atom. Here we have 4 different types of atoms pictured. Because an element is only made up of one single type of atom, what we have are 4 different elements because they are not touching or chemically bonded together. We have each one coming as an individual atom, not bonded to anything else. When we have elements like this, they would be considered monatomic elements. Most of the elements on the periodic table are monatomic. They come as single atoms and they can repeat over and over. These would be things like carbon, iron, copper, lithium, zinc, sulfur, phosphorus. These are all monatomic elements. But an element is only made up of one type of atom, so we have a different variety of elements as well. Here what we see is we have the same symbol together touching each other. This is called a diatomic element. When we have the same symbol in a pair and they're chemically bonded together, that is a diatomic element. There are a few diatomic elements on the periodic table: hydrogen, oxygen, fluorine, nitrogen, chlorine, iodine, bromine. Those are all diatomic elements. They come in pairs, so we use the same symbol twice touching each other to show that as a diatomic element. A compound is something that is made up of 2 or more different types of atoms that are chemically bonded together. Compounds are made up of 2 or more different types of atoms that are chemically bonded together. So anytime you see a particle diagram where there are 2 different symbols and they're touching each other, that means you have a compound if it is only that unit repeating over and over again. Compounds are pure substances because they're only made up of one unit. Right here, this could be an example of what is called methane, CH4. If we had a bunch of these red squares with 4 green dots touching them over and over and over again, that sample would be purely methane. The chemical formula for methane is CH4, so the red square would represent the carbon and the 4 green dots would represent the 4 hydrogens. What we see in a chemical formula is that there are 2 different element symbols that are next to each other without spacing. They also include these little subscripts. Those subscripts will tell you how many of that specific type of atom are in the compound. Here is another example. We have pH3, 1 phosphorus bonded to 3 hydrogen. Can you guess what the phosphorus is represented by? The triangle, because there's only one of them. Because there are 3 hydrogens, the filled-in circle represents the hydrogens. Here's a familiar substance, water, H2O. It comes together in this 2-to-1 ratio. Because there are 2 hydrogens and there are 2 blue circles, hydrogen is represented by the blue circle, while oxygen is represented by the unfilled circle. Homogeneous mixtures. A homogeneous mixture consists of two or more different elements and or compounds mixed with a uniform appearance and uniform properties. Steel is an alloy and it's made up of iron and carbon. So it's going to be uniformly mixed. So what we see here, we have different atoms. We have different atoms representing iron and carbon. So we have shaded and unshaded circles. But what we see is that they're uniformly mixed together. This is characteristic of a homogeneous mixture. Air is another homogeneous mixture. When you go through it, it's uniformly mixed. It's not like when you walk through the hallways of school, you have a breath that you breathe in full of oxygen, and then 3 steps later you breathe in nitrogen. It's all uniformly mixed, and in each breath you're getting relatively the same amounts of each one of those substances. So here, because we have a homogeneous mixture, we have different types of elements, nitrogen, oxygen, and argon, and a compound, carbon dioxide, CO2, that are all just mixed together uniformly. What we notice with our elements, with our compounds, and with our homogeneous mixtures, they all look the same throughout. If we were looking at them, we would not be able to see the different types of atoms that compose the elements, the compounds, and the mixtures. Our heterogeneous mixtures at the macroscopic level, the level that we see with our naked eye, are going to be much different. Heterogeneous mixtures. A heterogeneous mixture will consist of two or more substances mixed together lacking uniform appearance and uniform properties. How will we know that we have a heterogeneous mixture? We will see either visible layering or we will see visible clumping. That is how we will know we have a heterogeneous mixture. With heterogeneous mixtures, we're going to be looking for two things. One of those things is clumping. So at the particle diagram level or the submicroscopic level, we're going to be seeing clumping. What we notice here is this is an example with calcium and sulfur. Calcium is represented by these filled in red circles. What we see is the calcium is all clumped together, which would mean that at the macroscopic level with our eyes, we would be able to see chunks of calcium that were separated by the powdery sulfur all around. Another thing that we're going to be looking for is layering. Layering is a prime example with oil and water, something that we're used to. What we find is that there's water that is more dense than oil. It sinks down to the bottom, forming a layer that is clear, and then the oil is less dense and it's kind of yellow in color, and that always kind of floats to the top. We're going to see that here with heterogeneous mixtures. At the particle diagram level, we're going to be looking for layers and clumps. And at the macroscopic level, we will be able to see those layers and clumps. It will look different throughout. We will be able to see the different substances. So looking at this particle diagram, I want to ask you, how many different types of atoms are represented? What type of matter is this? How many different types of elements are there? How many different types of compounds are there?